Hello everyone. In this video, I will show you how to run a basic Java application with a database locally using Docker. This is a great way to isolate the environment and avoid database setup issues on different systems. As an example, we will use a multi-module Java application Spring Boot with a MySQL database. What is Docker? Docker is an open platform for application development used to support DevOps and developers. By using Docker, developers can create, package, deliver, and run applications as lightweight, portable, self-sufficient containers that can operate almost anywhere. Containers allow developers to package an application along with all its dependencies and deploy it as a single unit. The key concepts of Docker technology are images and containers. A Docker image contains everything needed to run the software. Code, runtime environment, such as JVM, drivers, tools, scripts, libraries, etc. A Docker container is a running instance of a Docker image. However, unlike virtualization, a Docker container operates on the host operating system's kernel. There is no separate operating system in a Docker image, as shown in this illustration, so it can be said that it is a local build for your educational project. Why do I say educational? But just because things happen a bit differently in production, you will most likely either use ready-made scripts or write them yourself. However, the essence will be very similar. Today, we will look at what you might call a light version. Easy peasy, Japanesey. This is perfect for your pet project. For example, if your project is a kind of backend for an application, or you've written a Telegram bot with a database, by not running your program in IntelliJ, you get something like a local server. But the truth is, it will only work while your computer is on. However, you can always run the built image on a cloud server. For example, AWS. One of our upcoming videos will be about this. Or maybe it has already been released. If so, a link will appear at the top. The entire process can be broken down into several stages. Creating a virtual network, creating an application image, creating a database image, and creating containers for the application and the database. Of course, you can launch the containers. This can all be done, so to speak, step by step. Alternatively, you can launch them using Docker Compose. Let's go. If you haven't installed Docker yet, visit the official Docker website and download the installation file for your operating system. Install Docker according to the instructions. It's quite simple. Once you do that, you can say that almost 50% of the work is already done. This is a convenient graphical interface. We have containers, our images. These are actually the two paragraphs you will need for your work. Of course, you will need to register here. You will gain access to Docker Hub, where you can store your images, but more on that later. Right now, you just need to install this. I am confident that at this stage you will have no difficulties. Let's return to our main program. The first command we will need looks like this. Docker network create docnet. So, what does it mean? As can be seen from the command text itself, it creates a network named docnet. This name can be anything you like. The main thing is for you to remember it and then type it without mistakes. This network will be used to connect the containers. This will allow them to communicate with each other by their names through DNS. If the network type is not specified, Docker creates a bridge type network, which is local and isolates its traffic from other networks. There are, of course, other types of networks as well. Host, overlay, MacBlend, and known. Each has its own features and areas of application, which you can always read about on the official Docker website. We run the command. An error occurs because the network. With that, docnet already exists. Let's take an example where Let's create another one, Docker2. You should also have a message like this. We have created the network. Now we need to create the containers that will communicate within this network. But containers are created from images. So first, we will create an image, and we will start with the database image. A logical question will arise. What difference does it make where to start? The difference is that during the launch of the container with our application, Liquibase will execute and attempt to connect to the database. And it doesn't exist yet. So the first step is to create and start the database container. We will not create a database image because images for all major databases already exist and are publicly available on Docker Hub. So we will just download it from the hub using a special command. It seems I already have it downloaded, so let's remove it. So, you see that. We don't have MySQL. Let's go back and run the command. You can see that the image is being downloaded. You just need to wait a little bit, depending on your internet speed. Let's go back to Docker and check. The MySQL image has appeared. Now we will be able to create a container based on this image. What do we need for this? Of course, there is a special command. It looks something like this. A few words about what is actually happening in this command. Docker run is the main command for starting a new container. T3307:3306 is an option that specifies that port 3306 inside the container, which is the default port for MySQL, should be mapped to port 3307 on the host machine. This means that you will be able to connect to the MySQL server on port 3307. This is both the external and internal port. Name.sql.conf. This is the name of your container. You will come up with it yourself. Network. Remember, we created a network once before, but I recreated it. Now it's called .NET2. Great. MySQL.root.password. This is the password for your database. And the name of your database at the end, MySQL, is the name of the Docker image that is used to create the container. Since we simply downloaded the MySQL image from Docker, it is named MySQL. The command is ready. We just need to run it. If you see this response, it means everything is fine. We are, of course, checking. We go into the containers, find SQL cont, just as we named it, and it started up right away. Now our database is waiting for a request. Let's continue. Now that we've dealt with the database, let's focus on the application image. For this, we need the command docker build tupimage. This is essentially the name of your image. You are free to come up with it on your own, however you like. In the end, we named the point, but to create this image, we need instructions on how to assemble it. First of all, we need to create a Docker file in the root of the project. You can always find a minimal set online. Let's take a look at it. This is, in fact, where we specify our JVM OpenJDK21. What do we need to copy into this image? I copy the END file with the variables there, our application jar, how it will be launched, and just in case, I specify the port. Everything seems fine. We specified where to find our jar file, but we still don't have it. But this is fixable, and we will get to that. I am sure that you have already corrected all the errors in the program, and your tests are running smoothly. This is a given. Let's open the Mammoth panel. I have it open here, and of course, we need to clean everything up first. Select the clean command. If you are a fan of the command line and do not trust interfaces, you can certainly install Apache Maven by visiting their official website. In the first link, there is a download and an installation instruction that is very easy, so there shouldn't be any problems with this. After you install it, with the simple command maven clean, we will achieve the same effect. So we have cleaned everything. Now let's start. And click on install and the jar files will be created. And there is one nuance here. If all the variables used in your application are specified, for example, in the application properties file or explicitly stated in the code. I don't know, of course, why you did that, since now they are accessible to everyone who has the code, and you can't store the code securely on GitHub, but let's assume. Then you can move on to the next stage. But if you have variables like keys for Zoom, for chat, for GPT, for a Telegram bot stored in an ENV file, in such a format, it is already much safer, because now your code can safely reside on the same GitHub, and no one will ever use your keys, especially since they could be worth money. I have exactly such a case. I use the .env library to work with variables from the env file when you run the program. In IntelliJ, you won't have any problems, but when building the image and working in containers, you will encounter an error indicating that there is no access to the env file. It will look something like this. Therefore, we need to make a couple of adjustments, specifically to specify the .env file where we will look for these variables. Initially, I had specified here. This is the standard use of .env, and when working among IntelliJ developments, you will not have any problems. It easily finds the .env file. I won't open it for now, as it contains all the keys, and it takes these variables from there and substitutes them. However, when working in the image, it encounters difficulties with this. We specify to it exactly where this .env file will be located. It will be placed in the app folder. That is why. We specified that we will copy the env files to the app folder, the one folder where everything will be stored, and our code will refer to the same location in search of the env files. That's why I commented this out and added a more precise expression. Now we can safely run the install. All the jar files will be generated for us. The jar file has been created. Of course, I had the code organized in advance. We are going with modules so that the main module is app runner. Actually, that's why we will use it further in the jar file from its folder. Now we are all set to create the image. Docker build app image. That is the name of our image. At the end, a period. Now we are starting. The image has been successfully created. Let's check. Now we can clearly see the app image listed in our list of images. We are back. Now we just need to run our image in the container. We use the .NET 2 network, an internal and external port, the container name appcont, a name of your choice, the database host we named container.sql.cont, and the internal port through which they will communicate. We also specified the name of our database and the database password, and the name of our image in which this container will be created. Let's say we see a successful command. We go to Docker in the containers, and we see that our SQL container is running. It's working. And the app is also running and working. How can we check this? Well, we have our Telegram bot. So we will just open Telegram and see if our bot is working. The bot responds, which means everything is working successfully. It prompts us to register. To ensure that it works through Docker, we go into our Docker and stop our containers. Let's just say app container. We return to Telegram. We call start once again. We see that the bot is not responding. Everything is great. It was a longer path, which can certainly be shortened if we use a special Docker Compose file. Then everything will start with just one command. For this, we will, of course, need a separate Docker Compose file, which will essentially contain the same commands, but in a slightly different format. Let's take a closer look at it. There are certainly some nuances here. Our Docker Compose file consists of two services. This is, in fact, the application and the database. This is, in fact, the application itself and the database. Let's take a closer look at each of these points. Here you have two options. You can specify the creation of a new image. That is, you write the build command again, the default context, and the instruction on how this image will be built according to the Docker file you saw earlier. Here it is. We don't change anything here. However, you can also create your image through the command line and send it to Docker Hub. Then your build will look like this. Here you have the application. Where can you get the image? Go to Docker Hub. This is my name on Docker Hub, and the image, in fact, is already there. Lattice is the latest version of this image. If you have something stored on Docker Hub, you can go there through the interface and take a look. I only have one image stored there. We have figured this out. The port is of course U880, and again, the variables of our database. We have a username, password, the name of our database again at the end of the app, and an important line, dependence on. This is a dependency. The build of this part depends on the MySQL DB. That is, in the second part. Remember, I mentioned earlier to maintain the order of creating and starting the containers. Therefore, this part will not execute until the MySQL DB is up and running. What is MySQL made of? Again, take the MySQL image. That is, when we write image, it signals to look for the image on Docker Hub. And our variables, again, are the password and the database name. Also, the internal and external port. That's basically it. We will set it up so that our new one is created. Let's take the ready ones, and we'll go into our Docker. We can basically leave those containers. They don't interfere with us. We can just stop them. And that's it. We just need to run one command and watch everything come together. The command is Docker Compose up. Great, ready for connection. Let's go into our Docker. We see our compose. It combines two clusters. Very convenient. We can see that our database is running. Now we just need to start our application. If we go to our development environment, the same commands occur. Full project build. Everything has started. Let's go to Telegram. We see that it has already replied to us. Well, to make sure, let's hit start one more time. Everything is running. Everything works with just one command. That's basically it. We have launched our Spring Boot application with a MySQL database using Docker. Now you have a ready-to-use development environment that can be easily reproduced on any computer. There's no need to spend a long time setting up a virtual machine. If you enjoyed the video, please like it, subscribe, and of course, leave a comment. It only takes you a few seconds, but it means a lot to us. See you in the next videos.